Hey, Chris, how are you?
I'm great, Rajiv. How are you?
Good, good. Hey, thanks for being here. I know you and I have been talking about this topic or the topics we're going to cover today for a while. So I really want this to be a conversation here, that conversation that you and I end up having over LinkedIn sometimes or chats. Thought we'll have that conversation here, and hopefully we can share some of our learnings with the audience. That's really what I want to do today.
Absolutely.
Since at the end of the day, it is about manufacturing, first of all, and more specifically, batch process manufacturing. More importantly, what I want to talk about here is that's the destination, right? We're trying to do things differently. But the foundation of all that is data, which brings us to the most important topic right now, which is, call it manufacturing data ops or industrial data ops, industrial data thread, whatever you want to call it. So that's really what I want to talk about today. And the one other thing I want to keep in mind is we know the reality of our industry, particularly in mature markets like North America or even Europe, is that we're applying all of this to brownfield. So things exist, operations are running, there are systems that are generating data. We got to deal with that.
And they're validated. Yeah.
and that's right. And in your industry, they're validated.
Yeah.
So you got to have that nuance in mind that we cannot, as much as we want to transform, we cannot revolutionize these things. Manufacturing is serious business. So just want to keep those things in mind. Now, with that, I've been in the automation industry for 30 plus years. I've seen it all from pneumatic instrumentation to 4 to 20 milliamps and protocols and digital systems, MES systems, all of that evolving. But I have seen it all from the vendor side, right? So I've always worked for the technology provider, right? Which can create biases in our minds. And I can say my way of doing is the right way because I'm right. But the reason I wanted to talk to you is you have a very different background than mine, because you have been in the industry as an end user, right? Even as an end user, your role has been that you had to serve internal customers. You were building things for people within your organization. So I think that's very important. So why don't you, more than an introduction, if you can tell your journey, things that you have worked on, the kind of people you've served. It's not just about your resume, it's about your journey. And some scars along the way.
That's right. Yeah. Well, anybody who has ever met me knows that my introductions usually spill into many examples of things. So yeah, I was raised in labs, basically. Like, I'm a PhD biomedical engineer by training. Kind of was heading down the academic career path and did a postdoc in London and got very soured with being in the labs. I was doing a lot of manual things. And that's really when that's what I tell everybody. That's when I got obsessed with automation, right? I worked in this facility that The Guardian called a cathedral to science, right? It was this Francis Crick Institute, this huge biomedical research facility. And people would go in on weekends and on holidays and exchange cell culture media. And if you've never done it before, it's literally removing liquid from a dish and adding fresh liquid. The most menial of tasks, and you're paying these PhD level and postdoc folks to do it. And I thought, well, this is crazy. Like, so Raspberry Pi and some pumps and tubes can do that. And so anyways, life happens, and I moved over into industry and moved back closer to family, and went to a large CDMO in the Northeast. And we were doing exactly the same thing. We were going in on weekends and on holidays and babysitting these bioreactors. And I thought, like, why are we doing this? All this stuff is digital. We should just be able to pull this data off automatically. So we did exactly that. We did some very cheap and cheerful data connectivity stuff, and it was a game changer for us at the lab at the time. And then I wanted to get out of the labs. Had been in labs for 10, 15 years and moved to another CDMO. And I found that the labs had no time to invest in PAT because they were spending all their time manually transcribing data. So it was the same story over and over again. They were running these high throughput experiments. So you've got 48 bioreactors that you're trying to monitor, and you're pulling daily samples and you're taking cell counts, and everything they're transcribing into paper batch records, paper lab notebooks, and retranscribing into Excel at the end of the day. So they were spending upwards of 20 to 30% just manual transcription. So of course they had no time for new technology implementation because they were spending most of their time just wrangling data. So that was our very first kind of digital transformation project, was in the labs.
So I want to come back to the data ops topic again, right? So it's hard nowadays that if you're talking about manufacturing data ops, that all you will hear about is these two topics, which are very relevant and important, but you hear about MQTT and UNS, and sometimes being presented as the be all and end all. And if you didn't know any better, you would say, oh, if I do this, it'll solve all my problems. And I just want to make sure this is not about MQTT UNS is bad. It's more about where and how to best apply it, because those are your learnings. When did it click on you? When was it clear to you to say, hey, just an MQTT broker and UNS isn't going to solve my problems?
Yeah. To me, it's when the questions that the business is trying to ask start involving more than just time series data. That's when my brain started to melt a little bit, thinking about like, how do I use this MQTT broker to handle batch style data? At one of our sites, we had a brand new senior director of operations, and 2 weeks of him working at the company, I set up a meeting with him. I just kind of wanted to see what he thought of the site and what were the problems he was facing. And he said, Chris, I don't know what's happening on the shop floor until I walk out onto the shop floor. And if you've ever gone onto a shop floor in pharmaceutical manufacturing, that's not an easy task, right? Like, you've got to take your street clothes off and you got to put gown up. Depending on where you need to go, sometimes you have to gown up multiple times if these are very clean spaces, especially if you're doing cell culture. So this is a time-consuming thing. So he didn't know where the batch was until he asked operators, like, have you done these different things? And so now you're starting to talk about pulling data from multiple systems. You've got to pull in MES data. You need to figure out, what's the status of this room? Is it clean or dirty? You need to pull in LIMS data to talk about like samples that have been taken or samples that are planned to be taken. And to me, yes, you could potentially do it in an MQTT broker, but it gets very complicated very quickly, which to me kind of defeats the whole purpose of the early projects that we had with our unified namespace. I loved the simplicity of it. Like the MQTT broker, you can see the topic in a hierarchical manner, and it all just seemed to fit nicely. But again, we started with time series data, so it worked great for that. But yeah, those complicated events and things that don't fit into this hierarchical namespace, that's also where things started to get very complicated pretty quickly.
Mm-hmm. Mm-hmm. Yeah, and like you said, in batch manufacturing, it's more than just equipment and materials and the sensors on them that are generating data. It's procedures and recipes and phases. That's really where the intelligence is. I once again want to clarify it, like you said, that UNS and MQTT have their place. Mm-hmm. It's a great technology. But you and I have had these conversations offhand, how passionate I am about it, in that manufacturing is not trivial. And what I see is almost like a populist type of hype going on there, that suddenly there's this magic bullet that's making it a lot more trivial. And along with that goes things like, oh, OPC UA is useless now, ISA 95 is irrelevant, ISA 88 and 95 are the villains. And then when someone like you, who has to go in and do a serious implementation in a manufacturing facility, you realize, no, those are, I can't just start simply building. This is not a hobby project. The point that matters to me is, yes, we need improvement in things like ISA 88 and ISA 95. With these newer technologies, simplicity doesn't mean trivializing things, yes. Right? You do want to use new technology to make things simple, but some people get misguided. Like you said, you look at it, it looks pretty simple, but when you start doing things, it's just one piece of the puzzle, right?
Yeah.
Which leads me to the next point, right? Which is the why of it all. right? Why is any of this important? We've been, like you said, we've been making product. We've had OT systems, data historians, MES systems. They've existed, right?
Yeah.
And they are all digital. So what I really want to talk about is the why of it, because I'm going to use a cliche. If you don't know where you're going, any road will take you there. So I often have these conversations sometimes with people after they've started building things with whatever technology they use to start building their data, when they get into, oh, I can't do this, I can't do this. So the best way for me when I talk to them is, you may be thinking that you're solving a problem today, but if you really mean this to be a serious data ops system that's going to scale at the enterprise level, if you don't know all the applications you'll be building, if you don't know all the business use cases you're going to serve, you should not start building these data systems. But in general, tell me, from your point of view, what is new with the digital? What is digital and what is digital transformation as seen by the business end users as they see it? Because I think that will help us guide to say, oh, those are the applications that matter. So tell us more about what is digital, which business personas they serve, once again, from a manufacturing and a batch manufacturing standpoint.
Yeah, I think that the use case we started with at first was one that probably could have been tackled many years ago with a historian, right? It was really just data plumbing. But my goal was to kill off an Excel sheet, right? Anybody who's ever worked in upstream manufacturing for biologics knows that there's this Excel sheet that everybody maintains, and it's daily samples you've got a bioreactor that runs for 14 to 21 days, and every day you're manually pulling a sample and you're running that, and you're getting things like how much food is available for the cells, how many cells are there, how viable are the cells, are they dying, very critical process parameters, and it's all logged in this Excel sheet. So that was my goal, was like, I'm going to kill this Excel sheet, because it comes down to just a couple pieces of equipment. And so that was our use case. And that was kind of where I was like, it worked. Like our MQTT broker idea worked. We had a data model for a bioreactor, and we had a data model for like a cell counter and metabolite analyzer, and we were just firing those to the broker, and then our historian was logging that. And then we used the API to pull the data out of the historian and bring it into Power BI. So what used to be an Excel sheet now could just be like a Power BI visualization. To me, that was very cool. And we kept kind of in a very nice, agile, iterative approach. We were adding in more data as we needed it. It followed that regular trajectory of the more you learn through this digital transformation process, the different kind of questions come up. This is great, but wouldn't it be cool if we had this other little piece of data? And so that's when we would go down to the shop floor and kind of connect it up into our infrastructure. But I think then it leads into kind of more complicated questions. Like this batch tracker is a great one that I, now being on an integrator side, I see coming up more and more frequently. It's the thinking of questions beyond the process historian. So even for mature sites that like all of our data already is in Pi or whatever, but now we have to fold in data from Pi and from LIMS and PAT data and from ERP systems to answer this question of, the ERP system says that this is when this batch is scheduled to happen. Well, why isn't that on schedule? And now you've got to go down to the shop floor and figure out exactly what's happening. Like, where is that batch in this thing? And so I think it's questions that maybe OT teams haven't had to answer, and now they have to come to the table with the IT teams who probably own the ERP system and own all the connections into this ERP system, and figure out like, how are we going to get these multiple enterprise systems to communicate together to answer this very complicated business problem.
If I can paraphrase it, what you said, essentially, the business problems are the same, right? You want to know how your batch is behaving. Is it doing what the ERP system asked it to do? But what the digital way of doing it is to get those answers should be on your tips.
Yes. Anybody
right?
who wants
Anybody's tips.
Yeah.
And the other is that multiple personas have questions about that batch. So they shouldn't have to, like you said, either walk the shop floor or go to OT, hey, pull up this data and answer these questions. I think that's a very good way to summarize, because as much as we use the word transformation, very little of it is biology and chemistry. I mean, they are doing their thing as to how do you make substances better. But from a digital perspective, what that's leading to is more people want more information, and we don't want to ask multiple people or pull data to have. So we want those answers, that information, multiple people, multiple personas should have visibility to what's going on and what's going to happen and what was supposed to happen. No, that I think that's a really practical way to summarize it. Sometimes we try to make it look more transformational than it really is. No, that's a good way.
And I think if you don't start with those problem, like the end goal in mind, it becomes too difficult. If you're just throwing out an MQTT broker and firing data off just to democratize data, like you're not adding, there's no return on investment there. Like you're not solving any problems necessarily.
Yeah. Well, now that you brought up data democratization, right? And I firmly believe in data democratization. In fact, what we just talked about, those business problems, a lot of those can be solved with data democratization. But I think even data democratization is very trivialized. So if I've just taken a few tags, given them a context on a topic, and somebody can, first of all, some of these brokers you can't even query. I mean, I don't want to go deep into the weeds of the technology. I'm sure you've lived with that. But coming back to data democratization means I can not simply that, oh, I could not see that data, now I can see it in a broker. That is not democratization to me, because if I can look at the data and get my answer. So simply having a tag's value, when you actually make that data useful, even a human, I'm not talking about a machine learning algorithm or something, is you say, okay, what was the average? You do averages, you do aggregations, you look historical aspects of that data, right? Even democratization is simply not just giving it equipment context and serving it up in a topic. That's probably the baby step zero of democratization. That is not democratization, right? Democratization requires data processing. It requires things that we have to do to make data useful to our brains to say, I can reach a conclusion. That to me is democratization. We'll talk about that hopefully in another day, about data products and democratizations. But let's come back to a couple of things that you touched on, right? So I'm coming back to manufacturing data ops, right? What it really is, right? We all know, and I think we're being informed enough that it is about context, right? And it's about making data available. So if you look at context, you could call it data modeling, you could call it UNS, you can say this type of ontology, I use ISA 95, I don't use ISA 95, it's all up to you. But at the end of the day, we only talk about context and serving contextual data. To me, that once again is a very small part of data ops, right? Coming back to, if you got those two things, is that the end? No, it's not, right? First of all, let's talk about context also. And since you've touched on a few things about product is being made, it's not just about equipment and sensors and models. We talk about equipment models, right? So that's one part. And then you talked about very different types of data, right? Time series is not the only data. If you can go maybe a second click on what you said, different types of data being, so can you add some detail to the nature of that data? First of all, it's different data types, but also context is more than equipment. Can you just do a second click on that from your hands-on point of view?
Yep. I think I've got a few like firsthand examples, I guess. One is PAT data. This is a topic that's very near and dear to my heart. And it was one that we encountered at a previous CDMO. Maybe this was probably 8 years ago or something, when we were doing PAT implementation in manufacturing. And I think we were one of the early adopters, which was pretty cool. PAT data, so we were using Raman. So this is spectral data, just like IR or whatever. So it's not time series, right? It's like these matrix. It's a cube basically. So it's wavelengths and intensities. And so the discussion came up about, well, how are we going to store this data? All we had out there, the OT team, all they had was Pi. Like Pi is not designed to store these cubes of data. And so what we ended up doing is like just basically taking these flat files that this machine output and just storing them on a file share drive out there, and it just died essentially. So like then you couldn't use it for anything. And this is like an incredibly rich data set, right? This is the molecular fingerprint of your bioreactor. And so to just put it on a shared drive was just so sad to me. Like, and it was all because I think we didn't have the data infrastructure in place to handle that type of thing. So to me, that maybe it's DataOps, but really it's bringing together kind of like these disparate data sources and solving a problem. So to me, the ultimate kind of end goal there is something like advanced process control, where you're kind of taking this PAT data and then feeding it back to the bioreactor and saying, we're predicting that the product is going to be out of spec in 14 days. Like, we better change something now to try to bring it in spec. And that's kind of the use case where you like the traditional, like just a historian alone isn't going to satisfy that use case.
So, one is storing that data. So you mentioned, if I can summarize that, so that's complex data. You called it a cube, right? So one is, like you said, there's no good way to store it and query it, but also now coming back to DataOps and publish, subscribe, and sending this data out, that data packet also, how do you transmit it? How do you make it available to other subscribers? I think there's a level of complexity to it that one really needs to look at which type of publish subscribe system, whether it's MQTT or something else, will allow me to handle it. So now that we are on that subject, closer to PAT is LIMS. So you mentioned that the data payload that was generated, which is that cube, right, is complex, but also there is an event with it. When was that sample taken? What phase was the batch in? And when you do it with manual sampling, who took the sample, when the sample, with all the information that's in the LIMS system, which is other than the sample characteristics themselves, that surrounding information, right? Yeah. Would you say, I look at that as that's very discrete information?
Yes.
It's not transactional, but it's very discrete. So would you not, if you had to serve it, let's say data democratization or an advanced analytics application or whatever it is that's going to run on top of this DataOps system, would need to consume that complex data cube along with everything surrounding it? How do you, have you tried to handle that with either an MQTT broker or some other system? I know some people that I talk to who are, they're using PubSub, but other techniques. But the point is that it's like even disparate data systems, sometimes when you don't do the second or the third click, you don't realize what that means. People just think, oh, that was system A and system B. No, it's very unique data and unique data type. So the way I look at it is, I look at the example of highways and streets. So if somebody says, hey, build me a transportation system for the city, that should be just one. And there's going to be little 30 miles an hour. The kids are crossing the street. That if I have to handle that as well. And then there's got to be a big transport going 70, 80 miles, but do it all in one system. And I asked them, well, what would you build a transportation system that way? So same way, to handle multiple disparate data sources while treating them as unified data, you have to put in mechanism. And this is where I say it's not trivial, right? And when you try to build it, it's not trivial. So it gave you the context of not just the equipment, but also where the cells were what the derivability was, have told you more about a state of the material. So once you have that, and if you want this to be then continuously served to multiple applications, right? So multiple subscribers at the same time, you don't know who might need it, right? It could be multiple users who are going to view it differently. What else do you have to do that data other than just simply joining it? What I'm getting to is whether it's that spectral data or a time series data, depending on how you're going to solve the problem, you're not just looking at its current value, right?
Yes.
You have to do aggregations, etc. Yeah. And if you're doing it in real-time systems, how and where does one do that data processing? Obviously, you're not going to do it in a historian, right? Which you can do for backward-looking applications, but for real-time applications, you won't. So what part of the DataOps system does one do that in, and what have you learned? Those are typically aha moments where you say, oh shit, I needed that calculation, but I can't do it on this broker. Tell me a little bit of some of those experiences.
To me, that's one of the limitations, I guess, of the broker is the fact that it only has current state. And that's why I've always, and I think I've posted about this before on LinkedIn, like I don't consider like your unified namespace, like the historian is such an integral part of that to me, because any sort of advanced analytics question that you're going to ask of your data, if you want to do some sort of a regression, or for maybe you're doing, I mean, the one that gets picked on the most is predictive maintenance, right? Like you want to tell me when the pump is going to fail next. And maybe you want to pull in some maintenance data to say, when was this pump last calibrated? You have to train it on this historical data set. I'd say like the modern DataOps players that are out there have the ability to pull both historical data and current state. So it's more than just having the data available in a broker, because depending on what question somebody's going to ask, there's always going to be more data that somebody needs. Maybe they're missing a tag. Maybe they need, like you said, different types of aggregations or smoothing or whatever. And so I always have kind of approached it as you want to put the plumbing in place to address those future questions, because you don't want to have to touch that source system again. Like you don't want to have to go through the change control process or editing documentation. Like you only want to touch the system once, and then you want to be able to add in more data as needed. And maybe a broker comes up, or maybe it doesn't. I mean, and a lot of the use cases that sometimes we come across, like the discussion around an MQTT broker never enters the chat, right? Like you're gathering up data and your end system is Snowflake. And what value is there to also firing the data to an MQTT broker? There's probably no consumers for that data that could speak MQTT that are looking for that exact data payload. And yeah, in that sense, like you're laying the roads rather than getting everything to this one single hub.
So we've talked about this complexity here, right? Just the nature of the business, right? We do want to use modern technology. We want to make things as simple as possible. And so I want to talk a little bit about, I don't want to use the term standards. So I'm going to talk about ISA 95 and ISA 88. And here's why I want to talk about it, right? Because one of the things is that just because it's controversial to get some clicks on your post, or if you can bash ISA 95 and say, oh, that was all the root of all our problems, it's too complex, you have to read something, which anyway, so this is my favorite topic. So allow me to rant a little bit on this, right? Because
of course,
no matter, so you've probably seen many of these, and I've seen millions of those, right? And these people, well-meaning people, influencers, experts, and educators who mean well, and because it's a very powerful visual, so you will see many versions of this, and the story goes something like this. The problem with manufacturing was all this pyramid, this ISA 95.8 pyramid, and my technology is going to flatten this pyramid. And that's what Industry 4.0 is all about. And that's going to be done by this unified namespace or this MQTT broker. It's going to break down that pyramid for you. And I want to be respectful here to the people I'm addressing. I respectfully would say that many of them have never read the ISA 95. The pyramid doesn't exist in the ISA 95. What they're talking about is the Purdue model, which was meant to represent how the enterprise is organized in functions. It was never meant to be how do you get data from point A to point B. Nowhere in the ISA 95 does it say that an ERP system must talk to an MES system and must talk to that before you go. So they talk about, oh, that was all point to point, and now this distributed and publish, subscribe. I really have no respectful word to answer that than to just say it is just pure BS. Educate yourself, please. It's very misleading. What do you think of the need for, let's call them standards or guidelines or whatever, right? Yes, they can bring complexity, but how do they serve you, and how to keep them relevant with these new technologies?
Yeah. I was taking notes because there were so many things that you brought up that I wanted to comment on. But I mean, for one of the first things that you mentioned too, I wanted to mention this in passing, is about how Industry 4.0 has somehow been tied to this concept of pubs, like this hub and spoke kind of architecture around MQTT. And I think Rick Bellata was the first one who kind of shared this with the community, but he sent a post, a PDF of the original German government document around Industry 4.0, and nowhere in there does it mention anything about MQTT or PubSub or anything like that. It's all about leveraging the internet to create these cyber physical systems. And so somehow it's gotten transformed over the years. And going back to your question around data models, like this is something that I think about a lot. We've had a number of conversations with SESME more recently as well around data models, and SESME has been very active at putting together workshops to kind of advance the conversation around here. So to put it in perspective, when I first went down this road 5 years ago or something like that, we made our own data model. And, in the broker, it was in ISA 95 format. So you got enterprise, site, area, line, cell, edge. And that made it kind of nice to browse through your data. Like in theory, if you didn't really know what data was out there, you could browse through the topical namespace, kind of like navigating through a file folder on your desktop. But it was our own data model. Like it was a bioreactor data model that we got together with a bunch of MSAT folks and said, look, I don't care if you're a little baby bioreactor in the lab or you're a 20,000 liter bioreactor out on the floor, you're going to produce exactly the same type of data. It served us well. We deployed it at multiple sites, and it evolved over time. So there were slight differences in different machines recording different data points. But to me, once I got involved more in Bioforum, so I've been in Bioforum on different work groups. More recently, it was in this digital integration of sponsor and contract organization working group called DISCO. And it was talking about exchanging data and information between sponsor organizations and contract organizations. And the kind of the core of the discussion becomes around, well, how do you create a common data model so that we can start to exchange data and information across enterprises? Like it's one thing to, you make your own data models within your organization, and it's hard enough to kind of make that work within your own organization across multiple sites. Never mind if you now want to exchange data across multiple enterprises. The ultimate end goal here, of course, it's a digital supply chain, right? I'm a CDMO, and maybe I make the drug substance and I ship that drug substance to another CDMO who's going to put it in vials or do the drug product formulation and filling. And I need to be able to inform that, but they need to expect some sort of common payload of data. Here's what you're getting. Here's the batch ID. Here's the certificate of analysis. It passes these tests. It's going to be coming next Thursday, that type of thing. But we kind of have to come to the table. So that's where I think there needs to be a broader discussion around standards that are out there. At least they're ones we should at least start with and use that as a basis for these parts of the standards work well. These are what's missing. But at least we're kind of starting with the same model to kind of work on. So we have at least a fighting chance of interoperability across the supply chain.
I'm glad you brought up that CDMO data exchange between organizations, because that's certainly that's when it starts to dawn on you, like I'm saying, this is serious business. Those are two business organizations exchanging data about materials and products and the state they're in, how they were processed, what was the quality at each stage, etc. They are not thinking about sensors and MQTT or what protocol it was, etc. It's a much higher level of data abstraction that one has to think about. So you need to think about it in your inherent design, right? Secondly, you use that example of the bioreactor. You created a model. So that is still a model of the physical part, right? The bioreactor is a unit op or a piece of a unit op, but it's physical. What about the model, data model of the product you're producing? The materials that are going into it, right? The phase, the recipe, where do you model that? Where do you create that data model, and how do you transmit that model, and how do you share that?
So again, this goes back to this is where it makes my brain hurt to think of like, how would you make that work in an MQTT broker? It was a conversation I was having with Jonathan Wise at SysMe, and he said, when an operator is on a piece of equipment, they're not a child of that equipment. They are related to that equipment at that time, but they are not, like, in a hierarchical manner, they are not a child of that equipment. So that's where that hierarchical topical namespace becomes a very limiting part of MQTT. I think there's been a lot more discussion more recently around these knowledge graphs and graph databases. And I profess to know nothing about graph, but it makes a lot of sense. Like these complex relationships, like the operator is currently interacting with this piece of equipment, and the operator has, you want to do some sort of analysis, like, is this operator even qualified to use this piece of equipment? And that type of analysis would be hard to do in an MQTT topical ISA, whatever you want to call it, like this topical namespace sense. Mm-hmm. But if you had a more graph relationship of, there's this quality management system that tells us that John Doe has these qualifications, and yes, he's good to go on this piece of equipment. He's got up to date with training. Those are the types of complex questions where it becomes suddenly like very challenging. And I think that's where I see the power of some of these, call it data lakehouses, platforms, your Snowflakes and your Databricks of the world, where you can start to do those types of joins across multiple data sets.
Or Quartic. I got to get a plug-in for Quartic.
Or Quartic.
No, I'm kidding. I don't mean to. This is not about Quartic. But I just want to add to it, because this is about knowledge sharing. So I come, like I said, my legacy is automation, and everyone knows I've worked with Emerson, and Emerson's a pioneer in batch, Provox first, and then Delta V batch, etc. And what I've done is, as I'm applying this to analytics, I'm applying some of those learnings. And once again, little plug for Quartic, I call it context in motion. And by that, what I really mean is when you do it in things like Delta V batch, there is the physical model, right? Then you're making a product, that's the product model. And you really bind the two of them together in runtime. And that's what I call context in motion. And that's how we are solving this problem at Quartic, because you need both. I have my own opinions about graphs, but I get your point but there are other ways than graph to solve that same problem.
Yes.
Before I go any further, I know people, as they listen to this podcast, I don't want them to think about this was about shortcomings of MQTT. But it's only because some people are presenting it as you can do it all. Yes. And they're wrong. And I want to call them out as they're wrong. And to be very frank, MQTT is an unbelievable invention. And I have nothing but great respect for Arlen Nipper. People who know him, he's the inventor, now part of Cirrus Technologies. It solved the biggest problems in SCADA. It has revolutionized the SCADA world. It's made SCADA much more accessible. You can make it cloud native now. You can overcome bandwidth issues. You can make it true distributed in SCADA for the modern age. But I'm sure even Arlen rolls his eyes when he hears this hype about you can do it for everything. Anyway, so we won't talk anymore about that. So let's move on to one more topic. It has become, just to talk about it, has become a method of living for people, which is the IT-OT divide and the IT-OT convergence.
Yeah.
I call BS on that as well, by the way. And the reason I want to talk to you in particular is the pharmaceutical industry. I looked at it as not yesterday, maybe decades ago, has solved this IT-OT problem. They have a discipline called manufacturing IT, which is very unique. And I'm not by any means saying that all organizations should have it. But let's talk about the IT-OT divide, because you have worked with IT teams, you have
Yes.
worked with business teams, you were the guy in the middle solving their problems. I personally don't think IT guys wake up in the morning to say, let's give these OT guys hell and let's make their life difficult. The way I see it is they are part of a larger function.
Yes.
The CIO's function, which is serving the enterprise. And we come across, no, I'm OT, I'm very special. I don't want to learn anything about your world, but you should learn about my Modbus or MQTT protocol. And tell me your views about, first of all, if it does exist in certain organizations, that divide.
Yes.
What are ways to overcome it? And some best practices and some reality on the ground, because you've lived with it.
I started off in the product development side, and then as I got into more digital transformation projects and into more manufacturing projects, like we were doing electronic batch records and MES deployments, I got sucked deeper and deeper into IT. So I saw the full spectrum, right? I was kind of raised on the automation OT side, good friends with the OT teams, and then also was in all of the meetings and had many discussions with IT leaders who kind of opened my eyes as to what are the things that keeps them up at night? What are they thinking about? Like maintaining all these enterprise systems and keeping the business running at an enterprise level across all 50 some odd sites. And the knee-jerk reaction from OT always is IT is just getting up in my business. I got to submit these tickets now to do anything. Like they're slowing me down. I used to be able to just go out and move things around on my switch, and now they won't let me touch any switches, and I got to wait 3 weeks to get a ticket resolved. And like that is based in, there's some reality there. There's some very real frustration. But on the flip side, like you said, like IT is not there to specifically to try to make OT's life difficult. They're trying to manage tickets across the entire enterprise and standardize switches for cybersecurity reasons. And they're trying to put these things in place for very legitimate reasons. So I think in some senses, yes, there is a divide. But I think it mostly is from a mindset perspective. Like I saw in IT organizations that I've been part of a failure of understanding of how the business fundamentally operates. And I think that is a very limiting factor. Like they will make some decisions based around some wrong assumptions about how the business runs and the priorities of the business. And that frustrates OT. Patches will be rolled out, systems will be updated without any discussion with manufacturing teams. Mm-hmm. These are lines that are running, producing things. Like you can't just touch these things, or these are validated systems. Like you can't do that. And so I think that both teams need to kind of come to a mutual understanding. And I think for IT, it's more like a walk out on the shop floor, see what's actually happening and what are the manufacturing flows, and this is how all the data flows together, and these are what these systems are actually controlling. Like I just think learning more about the business will only bring about good. And then equally from an OT perspective, because this certainly opened up my eyes, it's how do you put together an enterprise grade architecture? I'm from the lab space. I'm used to moving fast and breaking things, putting together with duct tape. Like that's just the world in which I live in. And that's just fundamentally not the way that IT thinks about things. that like they need robustness. They follow this ITIL for product for the delivery and long-term maintenance and hypercare and those sorts of things. So really it's just a discussion to be had amongst all. And we've tried that. Like we tried bringing all teams to the table, and it usually ends in these kind of fights. Like people get very backed into a corner. And so I think, yeah, it's just an open discussion to continue to have of learning and exchanging information.
Mm-hmm. No, that's why I personally am a big proponent of the manufacturing IT
Yes.
function, like I said, right? And I've seen it done extremely well. Sometimes there are people who came from manufacturing or OT and are part of this manufacturing IT function. So even though you might have these divides, resolutions are very quick.
Yes.
So I'm a big proponent of that. I wish other industries adopt this practice from pharma. I think it's worked out very well. Chris, we probably could talk for hours, and we will. We'll probably come back and hopefully bring others to dive into some of these topics at more depth. What I'm going to do is I want to summarize a few things that we've talked about so people can actually have some takeaways. Either they'll find useful and apply, or come back to us and to say. So I've really got 3 or 4 things, right? So the first one is, I said I wasn't going to go back to it, but I have to go back to it, which is UNS and MQTT is a great technology. Use it where it fits. Ideally in SCADA and frontline monitoring operations, that will be your best application.
Mm-hmm.
But don't fall into the trap that it can solve all problems in manufacturing. And I think you very clearly illustrated as to why, and you've lived with it. The second one, and I'd like you to summarize it for the audience, which is, that think about the destination,
yes.
Think about the applications. How would you, if you had to do it again, how would you go about saying, okay, let's think about, it's not as simple as what applications, it's more than that. So if you can.
I think the most successful projects that I've had and that I've seen now at other different companies are ones with an end goal in mind. Like something that solves a very measurable business problem. Maybe it involves MQTT, and maybe it involves a broker, or maybe it doesn't. Maybe it's just a DataOps tool and you're moving data into the cloud. Like, to me, I think that's when it's most impactful, is solving a specific measurable business problem.
Yeah. And I'll take the third one. And because, like I said, I've been through this journey of evolution of protocols, right? And to think and wait for this one communication protocol for all data types and all use cases and problems, I call it a fool's errand. It's like, it's probably harder than solving the world hunger problem or cure for crisis, or what have you. And it's for good reason. And like I use that analogy of, you don't build a freeway the same way you build a neighborhood street where children are playing, right?
Mm-hmm.
So if that's the case, how do you decide where to look? And the way I guidance, so people say, well, Rajiv, you are saying this and the other guys say this. I very objectively, this has worked. I say, look at what is the best fit that protocol was made for. So I used example of MQTT, made to solve the SCADA problem, low bandwidth, real timeliness, right? That's one, but that's not enough. Reality is you have to build. So look at what is the most supported, not most talked about. What is the most supported, the most installed? Reason being, you may put it in place tomorrow, you won't be there. There has to be an ecosystem and a support community around it. So look for that. And I'll go back to our introduction, that you also have, most of the problems you'll solve are with brownfield equipment and brownfield processes. And they have brownfield protocols, right? So don't fall into the protocol converters trap, because the goal I'm trying to achieve is make everything MQTT in my factory. So I should have OPC to MQTT converter, this to MQTT converter. And I've been there, done that. The more layers of protocol bridges and converters you add, the harder you make your life. And there was a time when we didn't have a choice. Now we have a choice. And once again, you want to use OPC with Kafka, you don't have to go through MQTT. So think about it that, remove complexity.
And I think kind of to add to that too, this is a conversation I had the other day. To me, there's nothing wrong with request response. That's a perfectly fine.
It has a fit. It has a fit.
Yeah. I mean, when my phone goes to check the weather, like that's an API call. Like so much of what runs in an IT perspective is request response. It's all through APIs. And I think that you don't need to throw that all away and try to replace it with some pub sub event driven architecture if it doesn't need it.
Yeah. And the fourth one, I took it from you, and it's great advice, as you said, in terms of understanding the IT team and what technologies they are using. I think that's the best thing we can do. Like I said, I come from an OT background. We think we're very special, but let's be real. We move a lot slower than enterprise IT does. So innovation and technologies that are happening there, we don't have to wait 10 years to use them as we've done in the past. See what your enterprise team is using and don't get stuck in, oh, I'm OT, I'm special, it's not going to work for me. Learn, maybe it can work for you. That will not only give you a great technology to work off of, you right off the bat, you will have this IT-OT working in
yes.
synchronicity, right?
Yeah, I mean, there could be problems that IT has already solved that you're thinking about. You know, I think data modeling and graph relationships are one that IT has been thinking about for a long time in the big data space. And I think OT is only just now thinking about it. But yeah, it's up to both of these teams to kind of come together and use some sort of a common language so they can understand each other in order to advance this problem.
Really appreciate your time, Chris. Really enjoyed this conversation. Always enjoy talking to you. And also what I like is people who have had to live in actually solving the problems. We all make mistakes. I don't want to even use the term mistake. We fumble. We learn by doing, right? If everyone could share openly by what they learned by doing to say, hey, this is great, but don't do this. You brought that, and I really appreciate it. Thank you for your time.
Sure, Rajiv. Thanks for having me.
All right.